Hello everyone, I am Harish Kumar from ECE department. Today I am going to talk about Michelson's interferometer and its contributions to astronomy. Introduction. Interferometers are devices employed in the study of interference patterns produced by various light sources. They are conveniently divided into two main classes, those based on division of wavefront and those based on division of amplitude. This is a diagram of lab interferometer. Interferometer theory. Instead of taking images of stars, an interferometer records the interference patterns or interference fringes created by combining the light from two or more telescopes. Interference fringes are created when light waves interfere consecutively. The result is a pattern of alternating light and dark bands. The working principle of interferometry technology consists of an splitting of the light into two beams that travel different optical paths and are then combined to produce interference. Interferometric objectives allow the microscope to operate as interferometer. Fringes are observed in the sample when it is in focus. Working diagram of Michelson's interferometer. Michelson's interferometer in astronomy. The Michelson's interferometer has played an important role in studies of the upper atmosphere, revealing temperatures and winds, employing both space-borne and ground-based instruments. By measuring the Doppler widths and shifts in the spectra of airglow and aurora. For example, the Wind Imaging Interferometer (WINDI 23) on the Upper Atmosphere Research Satellite (UARS), launched on September 12, 1991, measured the global wind and temperature patterns from 80 to 300 km by using the visual airglow emission from these altitudes as a target and employing optical Doppler interferometer to measure the small wavelength shifts of the narrow atomic and molecular airglow emissions lines, including by the bulk velocity of the atmosphere carrying the emitting species. The instrument was an all-glass filled, widened achromatically and thermally compensated phase stepping Michelson interferometer. All-glass filled, widened achromatically the thermal compensated phase stepping Michelson interferometer along with a bare CCD detector that imagine the airglow limb through the interferometer. A sequence of phase-stepped images was processed to derive the wind velocity for two orthogonal view directions, yielding the horizontal wind vector. History of Michelson's interferometer. One of the first uses of optical interferometer was applied by Michelson's stellar interferometer on the Mount Wilson Observatory's reflector telescope to measure the diameter of stars. The red giant star Betelgeuse was the first to have its diameter determined in this way on December 13, 1920. In the 1940s, radio interferometry was used to perform the first high-resolution radio astronomy observations. For the next 3 decades, astronomically interferometer research was dominated by research at radio wavelengths, leading to the development of large instruments such as Very Large Array and the Atacama Large Millimeter Array. Optical or infrared interferometer was extended to measurements using separated telescopes by Johnson's, Birds and Towers 1974 in the infrared and by Lebery 1975 in the visible. In the late 1970s, improvements in computer processing allowed for the first fringe tracking interferometer, which operates fast enough to follow the blurring effects of astronomical seeing, leading to the Mk1, 2 and 3 series of interferometers. Similar techniques have now been applied to other astronomical telescope arrays, including the Keck interferometer and Palomar disturbed interferometer. This is a picture of 20-foot Michelson interferometer which has been mounted on a frame of the 100-inch Hughes telescope in 1920. Current developments in Michelson's interferometer regarding to astronomy. Many large telescopes today use interferometry. Telescopes like the SKA radio telescope and the VLT optical telescope, they study the most extreme objects in the universe as well as hunt for exoplanets. Interferometry improve astronomical observation. It works by taking advantage of the wave-like properties of light that causes interference. Astronomical achievement. The Michelson interferometer is used for measuring the diameter of stars. In 1920, Michelson and Francis G. Pease used it to measure the diameter of Betelgeuse, the first time the diameter of a star other than the Sun was measured. Conclusion. The Michelson interferometer is a common configuration for optical interferometry and was invented by the 19th or 20th century American physicist Albert Abraham Michelson. Using a beam splitter, a light source is split into two arms. It is used to measure the small displacements made in open space. Thank you for listening. Have a nice day.